number 55 on section 5.3 says, a can in the shape of a right circular cylinder is required to have a volume of 500 cubic centimeters. The top and bottom are made of material that costs 6 cents per square inch, per square centimeter, while the sides are made of material that costs 4 cents per square centimeter. So this one is 6 cents, this one is 6 cents, and this outside part is 4 cents. Well, express the total cost of the material as a function of the radius of the cylinder. Okay, and then graph, and that's it. Okay, well let's go back to remembering some geometry formulas you should know. So volume is the area of the circle times the height. So the area of the circle would be pi r squared, and then times the height. Okay? Then we need surface area. But actually we need two different surface areas, because we need the surface area of the top and the bottom and the surface area of the sides. So the surface area of the sides is actually referred to as lateral area, so we'll just call it that. So lateral area would be the circumference times the height. So circumference is 2 pi r h. And then the top and bottom of that would be, here we'll just call it B for bases. Base 1, base 2. The bases would be an area of a circle pi r squared, but there's two of them. So 2 pi r squared. Okay. So I think the first thing we have to do is take our volume formula and solve it for h. Because the function is supposed to be a function of r. So let's solve our volume formula for h. So that means the volume is 500 divided by pi r squared. Do you see what I did? The height of the cylinder is determined by the fact that the volume is 500 cubic centimeters and volume is pi r squared times h. So h would be 500 divided by pi r squared. Okay. So then we use that and we substitute it in here. Okay? So the cost is going to be the lateral area times 4 cents, 0.04, plus the base area times 6 cents, right? So then let's go ahead and plug these formulas in. So the cost of r, the cost as a function of r, is the lateral area, 2 pi r times h. So 2 pi r, but then we're plugging in this number for h instead. So 500 pi r squared for h. And then we multiply that times 0.04, because that's the sides of the cylinder, right? And then the top and the bottom of the cylinder would simply be 2 pi r squared times 0.06. Okay, that's a rough function that I would say you could leave it like that. They might want you to simplify it a little further by, well, like for instance on this one you can cancel out the pi. You can get rid of one of the r's on the bottom there. You can go 2 times 500 times 0.04. What would that be? So 1,000 times 0.04 would be 3 zeros. That would move this 1, 2, 3. So 40. So 40 over r squared. No, not over r squared, because one of the r's canceled. And then plus 0.06 times 2 would be 0.12. 0.12 pi r squared. I think that would be a nice simplified version of our function. Okay? Okay, and then the next step says to graph it, right? divided by r, which I'm just using x, plus 0.12 times pi times r, which I'm using x squared. Now, to fit this in our window, we want a reasonable domain. So is the radius r going to be negative at all? Radius r is not going to be negative, right? Okay, so I've plugged that in like that. So I'm going to the window. 0. Any ideas of how big the radius might be? Oh, it's going to be bigger than that if the volume's 500. Just a shot in the dark. I don't know. 50? I don't know. Let's go with 50, see if it's big enough. So let's do 0 to 50. And then I'm going to do zoom fit. Okay. So there's the function as, but I don't think I'm seeing enough of it. Why 0 to 10?
The back of the book has 6,000 on top and on the side.
Oh. Okay.
We'd get it eventually, it would just take longer.
What is the question that's asked on this? What question is the book asking?
Book asked me, why is math so hard?
That is the question inferred by the book, not actually asked. Actually, that's the question that the book causes you to ask. Okay, Cody, what was it?
I don't actually.
Okay. Graph C. For what value of r is cost a minimum? Thank you. Okay, so we have to find the minimum of this graph. So we go second, calculate minimum. I don't know if I started the right place. It might not work right. Oh, it did work. So it says the minimum value happens when the radius is 5. The cost ends up only being $17.42, I think. You got a negative cost? So I see why it did 0 to 10, because it kind of like dips down in that area before it goes up.
Yeah.
Okay. So then the minimum value is at 5, 17.42. You can't see what I'm writing. Okay, so anytime you do a problem like that on the calculator, you should always sketch some sort of graph to show what's going on. That's a rough sketch.